Okay, today we're going to talk about proving specific properties in coordinate geometry. Please make sure that you take out a piece of paper, preferably graph paper, as not all of these proofs are in the packet if you printed out the packet or if you were handed a packet. So the first thing that we need to know if we want to prove something specific is our vocabulary. So it's very important that you understand when you see the word bisect, you need to think same midpoint. When you see parallel, you need to think same slope. When you see the word perpendicular, you need to think negative reciprocal slope. And when you see the word congruent, you need to think same length. Take a moment, hit pause, and copy these down. Okay, if we look at the first example, it says prove that the diagonals of parallelogram DOGS bisect each other. So the first thing that we're going to do is underline the key word. It says bisect. So we know that means cut in half or have the same midpoint. So my plan here, and again, it says the diagonals. So any parallelogram has two diagonals. I will use two midpoints to show the diagonals bisect. I'm going to hit pause for a moment so that I can do all the work, and then I will come back and explain it. Now, if we look at this proof, the first thing that I did after I wrote my plan is that I graphed the picture over here, and I drew my two diagonals in blue so that I could see that O to S is a diagonal and D to G is a diagonal. I wrote down my midpoint formula. I did the midpoint for those two diagonals here, and then for my conclusion, it's nice and short. Since the diagonals of OS and DG have the same midpoint, they bisect each other. That's all you have to do for that proof. If we look at the second proof here, it says prove that the opposite sides of a parallelogram, ABCD, are parallel. When you see the word parallel, I want you to think same slope. And the opposite sides in a parallelogram, there's 4 sides, so we're going to do 4 slope formulas. Once again, I'm going to hit pause for a moment. I'm going to do the work, and then I will come back and explain it to you. Okay, so now if we look at the work for my plan, I wrote I will use 4 slope to show the opposite sides are parallel. If we look at my work, I wrote the slope formula here. I did the slope for all 4 sides. When doing that, I noticed that this, AB, and CD have the same slope of 3 over 8, and BC and DA have the same slope, which is 5 over 2. So in my conclusion, all you have to write is since AB and CD have the same slope, they're parallel. BC and DA have the same slope, they are parallel. This shows the opposite sides of parallelogram ABCD are parallel. Again, it's all about your vocabulary. Okay, if we look at the next example, it says prove that the diagonals, so diagonals is important. We know that every quadrilateral has 2 diagonals. And then it says perpendicular. When I see perpendicular, I think negative reciprocal slope. So here, my plan would be that I am going to do 2 slope formulas to prove the diagonals are perpendicular. Once again, I'm going to hit pause, I will do the work, and then I will come back and explain it. So again, if I look at this, my plan is I will use 2 slopes to show the diagonals are perpendicular. I did draw my diagonals in so that I can see what letters I'm looking at, and I am looking at AH and MT. When I did my slope formula, this is -1/2. This slope is 2. Those are flipped and negated, which means they're negative reciprocals. So my conclusion, again, this one's nice and short. Since the slopes of diagonals AH and MT are negative reciprocals, they are perpendicular. Okay, that the last proof that we are going to do says prove that parallelogram DEFG has opposite sides congruent. When you see the word congruent, I need you to think distance And if we think of a parallelogram, it has 4 sides. So for this proof, we're going to have to do 4 distance formulas. Once again, I'm going to hit pause, I will do the work, and then I will come back and explain it to you. Okay, so now if we look at the work, my plan is I will use 4 distances to show the opposite sides are congruent. I wrote the distance formula down once so that I can use it for all 4 sides. When I do the distance, I found that DE is radical 20. I also found that FG is radical 20. And then I found that EF is radical 40 and GD is radical 40. If I look at my picture, that shows me that this side is equal to this side or congruent. This side here is equal to or congruent to that side. And my conclusion, I wrote since the length of DE and FG are both radical 20, they are congruent. The length of EF and GD are both radical 40, they are congruent. This shows the opposite sides of parallelogram DEFG are congruent. Again, if you have any questions, please make sure to write them down and ask me in class or email me.